How does Python reclaim unused variable memory? Have you ever wondered what happens to the memory used by variables in Python when they are no longer needed? Let's break it down in a straightforward way. Python has a smart system for managing memory, and it mainly relies on a process called garbage collection. This process works hand in hand with something known as reference counting. When you create a variable and assign it to an object, that object keeps track of how many references point to it. This is where reference counting comes into play. Each time you create a new reference to an object, its reference count goes up. Conversely, when a variable is deleted or goes out of scope, the reference count decreases. If the count drops to 0, meaning no references exist, Python will free up that memory right away. Now, let's talk about scope and variable lifetime. Variables defined inside functions or blocks are local to those specific areas. Once the block finishes running, those local variables lose their scope. This means their references are removed, which can lead to the reference count dropping. If no other references to the object exist, it becomes eligible for memory reclamation. But what about circular references? This is when two or more objects reference each other, preventing their reference counts from ever reaching 0. To handle this, Python uses a generational garbage collector. This collector organizes objects into 3 groups based on how long they have been around. The first group is generation 0, which contains newly created objects and is collected most frequently. The second group is generation 1, which includes objects that survived one collection. Finally, generation 2 consists of long-lived objects, which are collected the least often. The collector runs more often on younger generations because most objects do not last long. If an object survives a collection, it gets promoted to an older generation. You can also explicitly delete variables using the delete statement. This removes the variable's reference to the object. However, if other references still exist, the memory will not be freed immediately. If you want to manually invoke garbage collection, you can use the garbage collection function to prompt the collection of unreachable objects, especially those involved in circular references. Understanding how Python manages memory can help you write more efficient code. For instance, when working with large data structures, deleting variables that are no longer needed and invoking garbage collection can help reduce memory usage. Also, knowing that local variables lose their scope after function execution can help you manage memory effectively. In summary, Python reclaims unused variable memory through a combination of reference, counting, and generational garbage collection. This automatic management simplifies programming while ensuring efficient use of memory.